In this video, we'll generate the Gaussian integral dataset and trendline polynomial using Taylor-Maclaurin series sum with fact double and array formula. And we also use the ERF function, the Gauss function, complementary error function, and the NORMSDIST. We begin with the Taylor-Maclaurin series sum of the Gaussian integral, which is the summation of a times x to the power 2n plus 1, where a, the coefficient, is equal to negative 2 to the power n times factorial double of 2n minus 1. So it's the double factorial all over factorial of 2n plus 1, where the value of n starts from 0 to infinity. So we have 0 to infinity. And the coefficient will be equal to our formula minus 2 to the power n times fact double, that is the double factorial of 2 times n minus 1 all over factorial of 2 times n plus 1 and enter. Now we can generate the Taylor-Maclaurin series sum expansion array formula series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from at n equals 0, 1. So it starts from 1, followed by 2 times 1 plus 1, 3, 2 times 2 plus 1, 5, 2 times 3 plus 1, 7. So 1, 3, 5, 7, 9, 11. The interval is 2. And the coefficient, which is this range. Now we'll correct this error. This should be 1. So we use the if statement. If h or n is equal to if n is equal to 0, if n equals 0, then 1. Now we've corrected. And here you have the trend line and the trend line polynomial to the 8th degree. We'll calculate also using the error function and the Gaussian function and the NORMSDIST function. We begin with the error function. So array formula, ERF of the x values. That's the error function. Then the Gauss function. This is equal to array formula, Gauss of the x values. Now the complementary error function, which is equal to array formula, ERFC of the x values. And finally, the NORMSDIST, which is equal to array formula, NORMSDIST of the x values. Now we modify. Begin with the error function. So this is multiplied by 0.5 times square root of pi. So that's 0.5 times, and then multiply this by square root of pi times square root of pi. So the blue and the red datasets are the same. Their trend lines are also the same. Their polynomials are also the same. Next, we modify the Gauss function. There is a square root of 2. So multiply x by square root of 2. Then multiply square root of pi right outside. So that is times square root of pi. So the Gauss function and the error function and the Gaussian integral have the same datasets. Their trend line are the same. Their polynomial regression coefficients are also the same. Next, the complementary error function. So there is a negative x, so we add a sign negative. So the green has changed. Then we factor in minus 1 plus ERFC. So minus 1 plus error function. Now they're closer. And finally, multiply 0.5 square root of pi to the quantity. So 0.5 times the quantity and multiply square root of pi. So times square root of pi. Now all these are the same. Their datasets are the same. They're all in the same trend line. And their polynomials are the same. This is 0 because 9.24 times 10 to the negative 47. That's very small. That's already 0. 2.22 times 10 to the minus 16. That's already 0. Negative 5.07 times 10 to the minus 16. That's already 0. 2.69 times 10 to the minus 16. That's also 0. 6.54, it's not 0. It's the same as this. And 3 minus 3.88 times 10 to the minus 17, that's already 0. And finally, we come to the norms this line. There is a square root of 2. So times square root of 2. And then we factor in 0.5 plus, so negative 0.5 plus minus 0.5 plus. So you're getting closer now. And finally, multiply the entire quantity with square root of pi. So that's square root of pi times quantity. Now all these are in the same trend line. They're all in the same trend line and they are all equal. And their polynomials are the same. So this completes the use of factorial double, Taylor Maclaurin series sum, and array formula, error function, Gauss function, complementary error function, and the normal distribution function to generate the Gaussian integrals, polynomial, trend line, and dataset.